In this lecture, we will continue with the linear trend line focusing on residuals and fit in Eviews. The course evaluation dataset contains two series, Eval and GPA, where Eval is the average student evaluation of faculty teaching a particular economics course, and GPA is the average course grade assigned to students in that course. We have data from 23 courses. Let's create an equation object. In the equation specification, I type eval c GPA, click OK and name it. Eviews has created a linear trend line by minimizing the sum of squares of the residuals. Let's have a look at resid and c, two objects that are always created when you create a new page. Whenever you create an equation, the residuals will be saved in resid. Here are the OLS residuals from the OLS trend line and the course evaluation dataset. Resid will always contain the residuals from the latest created equation, and they will always be overwritten as soon as you create a new equation. If you want to save the residuals, you have to create a new series and set it equal to resid. You can do this either by clicking Quick Generate Series, type a new name such as E, an equal sign followed by resid. Alternatively, type series E equal to resid in the command window. C will always contain the estimated coefficients from your latest equation. Just like resid, it will be overwritten as soon as we estimate a new equation. You can save it by typing coef C01 equal to C in the command window. Here is the estimation output. We have the slope and the intercept of the trend line. Here you find r squared, which is equal to the explained sum of squares divided by the total sum of squares, or 1 minus the residual sum of squares divided by the total sum of squares. You find the residual sum of squares, sometimes called the sum of square residuals, here. Remember, the coefficients are selected such that this value is as small as possible. This is the least squares principle. The sample average of the dependent variable eval is here, and this is the sample standard deviation of the dependent variable. You will not automatically get a series containing the OLS fitted values. However, you can easily view them from View, Actual Fitted Residuals, and you can look at them in a table or a graph. If you want to save the fitted values as a series, click Forecast from the equation object and give it a name. You can also type eqo1.fit fitted in the command window. Let's check that the sum of squares of the residuals is correctly calculated using the sum of squares function. Type scalar RSS equal to @SumSQ of resid. Seems okay to me. You can also get the RSS directly from the equation by typing RSS equal to eqo1 dot @SSR. We can also check some of the results from OLS. Remember, we have the following results when we fit a linear trend line with an intercept using OLS. The sum of the residuals must be 0. To do this quickly, I'll just do show @SumResid, even though it displays the sum as a series. The reason that this is not exactly 0 is because of rounding errors. You can also type @SumResid, and the scalar result is displayed down to the left. The mean is @mean, and the mean of the residuals is 0, which is kind of obvious since the sum is 0. The next one is the sum of GPA times resid, which is 0. Unfortunately, Eviews will not allow you to assign the sum of a product like this to a scalar. You must first create a new series, say res GPA, as the product of residuals and GPA, and do the sum of this series. The sample correlation between the residuals and the explanatory variable GPA is 0. The sum of the fitted values, the sum of the dependent variable eval, and they are equal. The means are equal as well. No need to check this as their sums are equal. The sum of the product of the residuals and the fitted values is 0. And finally, the sample correlation between the fitted values and residuals is 0. You cannot directly find the explained sum of squares or the total sum of squares, but since you have r squared and you have the residual sum of squares, you can easily calculate them. We know that TSS is equal to RSS divided by 1 minus r squared, and I can type scalar TSS equal to EQO1 dot at SSR divided by 1 minus EQO1 dot at R2. ESS is r squared times TSS, and we can do scalar ESS equal to EQO1 dot at R2 times TSS. This is the value of ESS. Let's do one final check. The sample standard deviation of the dependent variable is equal to the square root of TSS divided by n minus 1. You find the sample standard deviation of the dependent variable here. If I do show at SQRT of TSS divided by 22, I get the same result.